This is Bryan Wenger with Wyoming DOT.
Once again, Bryan Wenger, Wyoming Department of Transportation. Wanted to talk to you today a little bit about Wyoming's Connected Vehicle Project. In September of 2015, the U.S. DOT awarded 3 cooperative agreements to design, build, and test connected vehicle pilot programs, one in Wyoming, one in New York City, and one in Tampa, Florida. So I'd like to just talk to you today a little bit about what we're doing in Wyoming. Just a little bit about what we're doing. We're doing it on I-80, the I-80 corridor in Wyoming. Want to talk to you a little bit about how what technology we're using to address some of our transportation problems, a little bit of a system overview, some fleet considerations, and where we're at on the project. So for those of you that are familiar with Wyoming a little bit, I-80 runs 402 miles across the Wyoming southern border. More than 32 million tons of freight travel through this corridor every year, and most of it is heavy truck traffic. Between 30 and 55% of it is truck traffic, with peaks of over 70% being trucks. This kind of shows where I-80 runs in Wyoming. Every day, somewhere between 11 and 16,000 vehicles travel this interstate every day, most of it the whole 402 miles. This shows a little bit of the elevation through this stretch. When you enter Wyoming in Evanston from the west, elevation 6,750 feet, Rock Springs 6,400 feet, Rawlins 6,700, Laramie a little over 71, and Cheyenne a little over 6,000. These areas are also very windy. Average wind speeds November to May, Evanston's at 7.5 miles an hour, Rock Springs almost 10 miles an hour, Rawlins 11 miles an hour, Laramie 12, and Cheyenne 11.5. So it's weather is definitely a consideration. I'd like to show you this video that kind of shows you some of the conditions that we go through. And here's an accident in 2015. We had the speeds reduced to 45 miles an hour. This crash involved 50 commercial vehicles and 20 passenger vehicles. Luckily, there were no fatalities during this accident, and I think some of that attributed to the reduced speeds. And about the time you think they got it figured out, it starts all over again. This is the one that amazed me that this car survived. pretty scary stuff. So this kind of shows you the blowing snow issues that we have through Wyoming. As you can see, it's some of the highest blowing snow areas in the country, anywhere from 100 to 650 hours of blowing snow annually through most of this stretch. Here's another video that we caught on a deck lid cam of one of our highway patrol cars that show that blowing snow is not our only issue that we have in Wyoming. We had 3 similar instances in the winter of 2015 to 2016 involving 3 of our highway patrol cars. Luckily enough, if the trooper was not in the car when that happened. So where we're doing this project on I-80 is one of the most heavily instrumented rural corridors in the United States. We have 136 variable speed limit signs supported by 94 traffic signals, traffic sensors, 54 variable message signs, 44 weather stations, and 52 webcams. So we figured, A, because of the amount of traffic and how much infrastructure we have in this area, that this was a great place to go ahead and do our test program. So the connected vehicle technology, we're using equipped vehicles to transmit and receive data from other vehicles and roadside infrastructures. And hopefully this will reduce the impact of adverse weather on trucks, give them more information, help them slow down and realize what they're driving through and what the conditions may be. And this is a pretty good video overview of it.
Interstate 80 runs east to west along Wyoming's southern border. This vital coast-to-coast route handles more than 32 million tons of deliveries per year. A high volume of trucks, combined with extreme seasonal weather, create dangerous driving conditions on this 402-mile stretch of highway. In 2016, there were 18 fatalities and more than 1,600 crashes, with over $865 million in economic costs to society. Improving safety in this critical corridor is a priority for the Wyoming Department of Transportation, or WYDOT. With funding from the U.S. Department of Transportation, WYDOT is deploying a connected vehicle pilot to help I-80 travelers get home safely. Here's how it works. Roadside units at hotspots along I-80 broadcast messages to onboard units and trucks that frequently use the highway. Onboard units communicate with roadside units and other connected vehicles, giving drivers in-vehicle alerts on the most accurate and up-to-date information on road conditions miles ahead. Onboard units inform drivers about adverse weather, stopped, distressed, or slow-moving vehicles, road closures and restrictions, parking availability, and active work zones. To ensure that the alerts and advisories are accurate, WYDOT also plans to collect real-time information from snowplows and other fleet vehicles. This is the future of safe driving. Learn more about the Wyoming Connected Vehicle Pilot.
So here are some of the project elements. We're doing this through dedicated short-range communications, our DSRC-based units. We're focusing on freight vehicles because that's what seems to cause most of our accidents. We're integrating this with our Transportation Maintenance Center. We're putting it in all of the snow plows that plow on the I-80 corridor and all of the highway patrol cars that operate on I-80 also. And we're just looking for the future, just trying to make this a safer route for people to drive. We're communicating on the public safety spectrum, 2.5 gigahertz, which allows for rapid connectivity as vehicles pass our radios and stuff, they can connect to them quickly, and information can be broadcast and received 10 times a second. So we can transfer a lot of information very quickly. So the two ways that it can communicate is vehicle to vehicle. They both have to have the connected vehicle devices installed in them, but they can send and receive information on speed, direction of travel, different alerts, so it'll know what the weather conditions are. If it's a snowplow, they've got sensors on them to tell if the wipers are going, road condition, or road temperature and stuff like that. They can also get information from our roadside units, which from the traffic speeds and everything, then it can let the vehicles know how fast things are traveling, directions they're going, and that sort of information. Also, we are installing an XM satellite receiver on the vehicles, so we can transmit that data either from our roadside units or through XM satellite. So like we talked, there's a lot of infrastructure there already, so we didn't have to add any fiber optics or anything. We're using all of our existing infrastructure, and we're using IP4 and IP6 routers to run most of this data through. So our goal is to install this on 150 to 200 large trucks, 100 small and medium trucks. We're partnering up with a lot of different freight companies and stuff throughout Wyoming. The Wyoming Trucking Association is also working with different partners to get this installed in different vehicles along with our own. We're integrating it through our Transportation Maintenance Center. It's going to be supported, and this information is going to help I-80 traveler information because we can gather more data. It's going to interface with our variable speed limit signs and other traffic management systems. And then here's a little overview of what we're doing in our units. We're putting it in 100 of our snowplows and highway patrol vehicles. In our snowplows, we're putting sensors on the windshield. You can see one here. It's going to tell if the wipers are on. There's external sensors on the truck that'll pick up road conditions, temperature, stuff like that. I've got a little display here and a demo that kind of shows what it looks like in the vehicles installed. So kind of like we talked, it can communicate vehicle to vehicle, so it can communicate from our snow plows to any of our connected vehicles to the highway patrol cars back and forth. It can communicate, it'll receive and send that information through our roadside infrastructure, and it can then also, if we send information through satellite, it can actually receive that stuff through XM satellite also. So here's just one of the onboard units that'll kind of show you information. It'll give you, if there's a connected vehicle in front of you, if you're about to run into one, it'll give you alerts. I think that's what it's doing right now, saying that you're getting too close to another connected vehicle. It'll give you road conditions, weather conditions, just to hopefully make the drivers more aware of the conditions so they'll drive accordingly. It'll also tell you if you're coming up on work zones, so hopefully they'll slow down through the work zones. If a motorist gets stranded and they hit the distress signal on their connected vehicle, it'll mark that location. It'll let you know where those vehicles are. Here's kind of some of the different situations that you can run into. Forward collision warning. So if you're coming up on a snowplow, it'll tell you that you're approaching a connected vehicle. You need to slow down. If somebody breaks down, hits our distress signal, it'll mark that location, send out distress notifications, inform highway patrol of where they're at, and as you're coming up on those stranded vehicles, it'll give you alerts. Situational awareness, so that you know what the weather conditions are, what the speeds are. Work zone warning, so they'll know where they're coming up on either accident areas or work zones, so hopefully they can get them to slow down. Let them know what the weather's like, so if it's windy, snowing, raining, whatever, just give them more information to hopefully get them to slow down a little bit. So we're integrating it with our transportation, our TMC center. We're going to integrate it into our existing traffic management software, so hopefully they'll communicate back and forth together. You can use this information to better enhance our road reporting conditions. We just can gather that much more data. Use it for our 511 system. We're going to make this data available third party, so if different companies want to use this data to help alert other people, that's going to be an option too. So some of the fleet considerations, this is what a complete system looks like installed in our vehicles that we're outfitting into the highway patrol cars and the snow plows. Similar systems will be going into the private fleet as well. Once the system's installed, all the drivers have to go through driver training. We have an online training that they can attend. We also have a simulator set up at the University of Wyoming that the drivers can go sit down in a simulator, and it kind of walks them through all the procedure on how to use the system. Here's a antenna mount that we're doing on our snow plows. 2 antennas have to be mounted on top of this unit. It has to have clear line of sight to vehicles all around it, so we made adjustable mounts so we can get it just over the headache rack but not have it too high. Complete system takes about 2.5 hours to install. So here's just a couple pictures of one installed in our our snow plows. We were already using this Samsung tablet for pre-trip and weather applications, so we're using the same tablet to do the connected vehicle stuff. There's also different ways that they can get this information. They make smaller units that are like rear view mirror cameras, so they don't have to have this big display if they choose to have something smaller in a private vehicle. We've got it in a couple highway patrol cars we're testing now just to make sure we don't have interference with their radio equipment. As most of you know, these patrol cars have a ton of equipment in them, so packaging was definitely an issue. We're getting it figured out. This just kind of tells that we're encrypting all this data. We're making it as secure as possible. We're not sharing this data with anybody else. All the private vehicles that this is installed in, we don't know who it is. I mean, it's a vehicle out there, but we're not sharing that data saying that this is a Swift truck running down the road, this is a UPS truck. It's just a unit number. I mean, we're not using it to tell highway patrol how fast, if somebody's speeding or anything like that. So we started this project in the September 2015. Concept phase was 12 months. We're moving along quite well in phase 2 of it right now. We're doing a lot of testing. In fact, the last few days, we went ahead and ended up renting a 53-foot box trailer from Penske, installed the unit in one of our trucks just to make sure we've got connectivity like an over-the-road trucker would have. We've had some issues because those trailers are so tall we can't do a cab-mounted antenna. We're doing mirror-mounted antennas. The first one that they come up with didn't work very well, so they've developed another antenna that we're testing now, wanting to get the system perfected before we send it out to the public to install into their vehicles. Any questions?
So how successful are you at getting private partnership buy-in into this?
Once you show them these videos and they know the impact that it could potentially save their companies, we've had real good success. I mean, a lot of people are definitely jumping on board just to, hopefully save their trucks from damage.
Do you have any of these guys, because it seems like to me probably a lot like Nevada, most of these guys aren't based in Wyoming, they're probably traveling through.
A lot of these we're partnering, they are based in Wyoming. They're fuel haulers or they're freight companies that pretty much travel through Wyoming. They might go into Utah or they might go into Nebraska, but primarily they spend most of their time. A lot of Wyoming-based companies.
Okay, so what about the guys that are traveling through? 'Cause I bet most of your truck traffic is probably out of state.
Correct. Yeah, for this pilot program, we're trying to concentrate on stuff that's going to spend a lot of time in Wyoming so we can get as much data as we can to start with.
Hey, Bryan, about how much does a unit cost roughly?
They say $300 to $400 is what they're anticipating the unit will cost. Yeah, and I think it depends on what they do for for a display. Ours, we already have the displays in the plows, so it definitely isn't as much, and that wouldn't be any labor to install it, but
Bryan, in addition to the cost, is that proprietary to any specific vendor, or is that something that?
and I'm not sure how they're gonna do it. Like I say, we're doing all this testing and all this stuff in-house right now. I think once they perfect the system, I'm not sure what they're gonna do with it, but it's,
And then how do they actually procure it? They procure it from you guys?
we give it to them,
Oh, you give it to them?
right,
So the tile is basically paying for it?
exactly.
Thank you, Bryan.
Sure.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.